Start. Okay, let me also give you show you the corresponding topics, corresponding what material that is there in the textbook, so that you should not feel that okay, I'm just doing somewhere and then you're not getting the material. So let me just start from showing it from the PDF itself. This is the textbook what is being shared with all of you. So we are looking at that common gate amplifier. Let me just This is common gate amplifier. Okay, I'm getting some background noise from someone else. Make sure that okay, that is not there. Okay, now this is the common gate amplifier. So as it was discussed in the earlier class also, an amplifier will be called as a common gate or a common amplifier or common terminal amplifier, depending on which terminal is taken as common with respect to input as well as output. So if you consider this VB, that is gate, and of course the input is applied to the source and output is taken at drain. Am I correct? Okay, who is there with me?
Yes,
Shilpa?
sir.
Yeah.
Yes, sir.
Suppose if you write the AC equivalent of this, so does this VDD be grounded?
Yes, sir.
And how about this VB? VB is also a DC voltage that will also be grounded. Am I correct?
Yes, sir.
So since this is grounded and since you are applying the input, you can see input applied to source. So input is applied to source. This is Vin. So are you measuring with respect to ground here?
Yes, sir.
And since gate is ground for both output as well as input, so and it is AC grounded, we call this amplifier as common gate amplifier. Common gate amplifier. I think we have derived the expression for common gate amplifier. Suppose if I just share my camera, and then I think this is how we, where is that common gate amplifier? Yeah, I hope this is that.
Yes.
Did we do common gate amplifier? Yes, I think this is that
Common
common
gate and
gate
common
amplifier.
drain.
If you can see here, this is the VB, the bias voltage, and output is measured. Output is measured at the drain point. So this is drain, this is source gate, and output is measured here. Input is applied at the source. Since this is AC grounded, and you are applying the input with respect to ground, measuring with respect to ground here, measuring the output with respect to ground. So will it come something like this here, this expression,
Yes, sir.
this
Yes, sir.
small signal model? So what
Yes,
is
sir.
V0? V0 is equal
We
to
notice.
current I0 multiplied by RD. So this is what is I0 RD. But this I0 is opposite to this current. That's why it is written as I0 is minus Gm into VGS. Correct?
Yes, sir.
This VGS, whatever this VGS, is exactly the minus of Vin. See here?
Yes, sir.
So this is VGS is minus of Vin. So upon substituting that, we'll get V0 as, of course, minus of minus will become plus. It is Gm into RD into Vin. So upon taking the ratio, the voltage gain becomes Gm into RD.
Gm into RD.
Perfect?
Yes, sir.
Yeah, that's what is there given in the textbook. See here, Gm into RD.
Yes, sir.
So
Minus.
there is no minus. See, there is no minus here.
Equal. Okay.
This is equals. Okay, this is how I'm just trying to map the material that is in the textbook and what we derived in the class. Okay, this is what you have. Okay, let me just go around here. Of course, you are applying a small input voltage. Can you see an amplified version here?
Yes, sir.
You can see an amplified version, and most interestingly, it is in phase. See, if your input is increasing, output is also increasing because there is no negative sign. Because you can see there is no negative sign here. Correct?
Yes, sir.
Okay, let me just, of course, we are supposed to find what is the input impedance as well as output impedance of this amplifier also. So as we found in, what is that? CS amplifier.
CS amplifier.
Few parameters that are important to know for any amplifier is what is the voltage gain, what is input impedance, what is output impedance. Suppose if you consider what is, okay, how do you measure input impedance? So you apply the input voltage here.
Yes.
You apply the input voltage Vx at the input port, and here okay, let me just do it in my textbook or in my notebook. Okay, how to find the input impedance. So the task is now to find the input impedance of what?
CG.
CG amplifier.
CG amplifier.
Correct?
Yes, sir.
CG amplifier. So let me write the CG amplifier here. This is VB. This is now VDD. This is RD. Here you are supposed to, this is your input. So let me apply a source Vx. Correct?
Yes.
So
Yes.
this is Ix. Correct?
Yes, sir.
So what is the typical procedure what we follow for finding the input impedance? For finding the input impedance, so this is Vx, this is Ix. You open circuit the load. Correct? This is the
Yes, sir.
amplifier. This is the amplifier. This is your open circuiting the load. So what I'll do, I will open circuit this. So what I'll do, when I want to write its AC equivalent, will I ground the DC voltage?
Yes, sir.
So VB is grounded,
Grounded.
and then you
VDD is
have this. Of course, VDD is also grounded, and since it is open circuited, so that is not visible at all. Correct? This is open circuit,
yes,
no?
sir.
So it's
Yes, sir.
something like this. Correct? This is RD is infinity. Infinity, you are open circuited this because this is your load.
Yes,
Correct?
sir.
So this is Ix, and you are trying to find what is Vx. Correct?
Yes, sir.
Okay, let me AC ground that one. Okay. Now, what is this you are trying to have now is, so now when you are looking into the source, if this is AC grounded, what are the resistance you are going to see? That's what we have seen in the earlier classes. No? If you see here, see this, who is there with me?
Shilpa.
Okay, Shilpa. Suppose if you are seeing from the source, what are the resistance you will be seeing?
R 1 by GM
Parallel R naught
total with
if
A naught.
lambda is non-zero.
Yes,
Correct?
sir.
If lambda is 0, what is this R naught?
R naught.
What will be R naught if lambda is 0? If lambda is
R.
0, R naught is infinity, no?
Yes, sir. Yes, sir.
So, if you are looking into the source, is the resistance 1 over gm?
Yes, sir.
Is the resistance 1 over gm?
1 over GM.
Correct?
Yes, sir.
So, what we have now is, so the resistance is 1 over gm now.
GM.
That's what you have here.
Yes, sir.
See here? R in is 1 over gm.
Yes, sir.
So, we will try to find out what is,
Input.
of course, that's
Input
what is given here.
impedance.
That's what is given here. Ix is equal to minus gm into so and so. So
Yes, sir.
if you want to derive the expression for that. So what are the current that is flowing? The current that is flowing is minus gm into
GM
V1.
into
Of course,
V1.
instead of V write VGS, they have written it as V1.
Yes, sir.
Correct? So that V1 is minus of Vx. So that's why this minus will go whenever you write this V1 by Vx. Whenever you write V1 by minus Vx, so this minus of Vx and this minus will go up, you'll end up with gm into Vx. Correct?
Yes, sir.
Then what is Vx by Ax? So that is 1 over gm.
1 over G.
Correct? So this is
Yes,
exactly
sir.
the way how we derived earlier also.
Yes, sir.
And similarly, what is output impedance? See now. So let me write what is the output impedance now. So how do you write the output impedance? So what I'll do now. So what is the procedure for finding the output impedance? This is amplifier. Is it Vx? And then Ix, you short circuit the input. Correct?
Yes, sir.
So this is your input, no? Usually at the source you'll apply the input, you ground this.
Source.
Correct?
Yes, sir.
Since it is VB, I'll ground this also.
Yes, sir.
Correct? So now
Yes, sir.
let me try to ground this also. This is RD. Correct?
Yes.
So now you write the small signal model. This is gate, this is source,
Source.
this is GM into VGS,
VGS.
this is drain. To the drain you have connected an RD, and of course
RD.
since you want to find the output impedance, you have connected a VX here. This is
Yes.
Vx and this is Ix. Am I correct?
Yes, sir.
This is ground, this is also ground, this is also ground. Am I correct? Source is
Yes, sir.
grounded, gate is also grounded, and what is this? VG is also
VGS.
0 because this is ground, both are 0 0. So this is Vx, this is Ix. Correct?
Yes, sir. Yes, sir.
So when VGS is 0, what happens to this?
Z
This will become
0.
open circuit. Current 0 means open circuit, no?
Yes, sir. Yes.
Shall I write Vx by Ix, which is nothing but R out, as equal to RD?
Yes, sir.
This is what you have here.
R
R out
out
is
is
RD.
equal to.
Correct?
Yes. Yes, sir.
Uh, of course, when we are considering this particular case, so we are considering the output resistance as RD. So with RD in place, you are trying to find what is the input impedance as well as output impedance. If you take out the RD here, so then this will become infinite. Correct?
Yes, sir.
Okay. Okay, now let us see this now. Uh, let us study the behavior of CG amplifier in presence of finite source resistance but with still lambda equal to 0. See here now, what is the difference
Yes, sir.
between the previous circuit and this circuit? So previous circuit is this, which is the previous circuit. Previous circuit is something like this. So you applied an input voltage V in. Now you considered an ideal input source. What do you mean by ideal input voltage source? Source resistance is what? 0.
0.
So source resistance of the source, not this source,
No.
not the source of your MOSFET. You have an input source V in, no? So that has got 0 resistance.
Yes, sir.
Coming to my camera. So here we had this source, no? Where is that? So this was my V in source. So assume that not the input impedance. Let me just come here. Here, this is my V in source. This because every source is associated with an R signal. Am I correct?
Yes, sir.
So if this R signal is 0, this is a circuit because you didn't consider any R signal.
Yes,
Correct?
sir.
So now in such case, suppose if this R signal is non-zero, if we consider some resistance, let us see how it happens. What is the next case? Next case is, let us study the behavior of
Ours.
CG amplifier in presence of finite source resistance. This is what? RS is the finite source resistance of this source. Correct?
Yes, sir. Yes, sir.
Let us try to understand, okay, how to analyze that one. So let me consider the same source or same CG amplifier. Okay, will I apply some bias voltage? I'll connect RD. This is VDD. This is my V0. Correct?
Yes.
So here, instead of having a source which is simply V in, I'm
VN.
connecting instead of
RS.
writing R signal, sorry, RS, I will write it as R signal so that you can understand R signal is the resistance of the signal source. Correct?
Yes, sir.
Suppose if I write RS, you will think that okay, that is the resistance that is connected to source. I'm
Yes, sir.
specifically writing it as R signal so that this is the resistance associated with the source. Correct?
Yes. Yes, sir.
Now, when you have something like this R signal, so looking up here, how much resistance that you are seeing? Looking up to the source,
R.
how much resistance you are seeing? That's what we saw now. What is the input impedance of this? Is it not 1 over GM?
1 over GM, yes sir.
This is 1 over GM. So if the resistance seen here is 1 over GM, if this is V in, if this is R signal, suppose if I write this voltage as some Vx. Vx is what? It's the AC voltage that is available to the source. Because of this, there is an R signal. If there was no R signal, whatever voltage is V in, that was coming here. Because there was no
Yes sir.
drop here. Suppose if R signal is 0, what is the drop here? 0.
0.
Since there is some R signal, there is some drop. Am I correct?
Yes sir.
So let us consider the voltage that is there available at this source due to the input voltage, due to R signal as the signal resistance, and 1 over GM as the resistance seen by the
Resistance.
entire network as the input impedance. Will I rewrite it as something like this? V in R signal
Or
and 1 over GM. Shall I write this as Vx?
S.
Then what is
Yes sir.
Vx? Can I write Vx
1.
as equal to V in very simple potential divider 1 over Gm
1 over GM.
R signal plus 1 over Gm.
Yes sir.
So does this become the input for your CG amplifier?
Yes sir.
So shall I now write V naught by Vx,
Vx.
because this is now the input, is equal to
Vx.
Gm into Rd.
Yes sir.
But what is what do you want is V naught by V in, no? Your gain is V naught by V in.
Yes sir.
So shall I now write this as V naught by Vx into Vx by V naught? Sorry, V naught Vx by V in. You just multiply and divide by Vx.
Yes sir.
I'm just multiplying it by Vx and dividing it by Vx. Will there be any change here?
No.
So what is Vx by V in here from this? Can I write Vx by V in as equal to 1 over Gm R signal plus 1 over Gm?
Yes sir.
So shall I now write AV is equal to 1 over
1
Gm
over
by R signal plus 1 over
plus 1
Gm.
over GM.
This is what? This ratio. How about this ratio V naught by Vx? Is it not Gm into Rd?
AV. Yes sir.
So we are replacing this V naught by Vx as Gm into Rd. We are replacing Vx by V in by this ratio. So the product of this is the overall gain.
Yes sir.
That's what is there here. See here? That's what whatever I have written in my notebook, it is exactly the same. Vx is 1 over Gm
1 over GM.
multiplied by V in divided by sum of these two, which is a potential divider.
Yes sir.
Of course, which you can rewrite it as 1 over 1 plus Gm into Rs. That's further simplification.
Yes.
Can I write V naught by V in as V naught by Vx and Vx by V in?
Yes sir.
And finally it comes out to be this. So let me also just give you that expression. So can I rewrite this as of course 1 over Gm, you just retain it as it is. Let me take out 1 over Gm outside. Is this 1 over Gm Gm
R
into
signal.
R signal plus 1 into Gm into Rd? So does this go
Yes
with
sir.
this? So do you end up with now Gm Rd by 1 plus Gm into R signal?
Yes sir.
This is AV. This is what you had here also. You can see, of course, which you can further write it as. You can see Gm into Rd by 1 plus Gm into Rs.
Yes sir.
Correct? Which you can take out again Gm outside. Of course, it is one more form of writing that. What is this now? Why we actually derived this? So actually you can see
What?
AV is equal to Gm into Rd if R signal is 0. What do you mean by R signal
Yes sir.
0? It's an ideal voltage source.
Yes, sir.
For a voltage source, if the resistance is 0, will you call it as an ideal voltage source?
Yes, sir.
It is. If there is some source resistance involved with that voltage source, the voltage gain reduces due to the presence of R signal. How much is the reduction? It is as per this equation. Suppose if you can see here, if R signal is more and more, does AVs keep reducing?
Yes, sir.
So what is the ideal value of R signal? R signal to have a better gain?
R signal is ideal.
Ideal value. What should be R signal ideal value to get good gain? Ideal value is 0.
0.
Typically it should be less in terms of few ohms, 10 ohm, 20 ohm, 30 ohm, fine. If it is in terms of tens of kilo ohm or ones of kilo ohm, you will have a very poor gain.
Yes, sir.
Correct?
Yes, sir. Yes, sir.
Okay, let me just know from all of you, maybe just put in chat box. So, would you able to get the effect of R signal on the gain of your CG amplifier? Just say yes, no, got it, or once again, just put in your chat box. We did nothing great here. We actually consider that R signal. We are now effectively finding what sorry, what is the effective input voltage that can be applied to the applied as input now because of this R signal. So it will not be a Vin as it is, but it will be a reduction in that value. That depends on what is your node GM and what is R signal. So it comes out to be something like this. So Vx is given by this, and then you are asked to find what is V0 by Vin. So you just divide multiplied by Vx, and of course you'll end up with this expression. Just put in the chat box. I'm not getting any responses. Make it fast. Make it. We don't have too much time. If anybody has any doubt, let me just know from you.
The source resistance acting as a degeneration resistance.
No. It is not exactly like degeneration, because in case of degeneration, the signal was applied at the gate.
Yes, sir.
Actually, the R signal will actually reduce the amount of voltage that is going to the amplifier. Because assume that if you had, okay, let me just show you here. Suppose if you are applying some 10 millivolt, if this R signal was 0, the entire 10 millivolt would have gone here. Because of this
Yes, sir.
R signal, there can be some drop of 1 millivolt. That depends on what is your node GM and what is your R signal value. So effective
Yes,
voltage
sir.
that is reaching here is 9 millivolt. But that doesn't mean that whatever 9 millivolt you get as the input, that will be multiplied by GM into RD. So amplifier is doing its amplification, but because of this R signal, the amount of voltage reaching here is reduced.
Yes, sir.
It is not the degeneration. In case of degeneration, it was totally a different analysis, because when you apply some input voltage, current was trying to increase, then the feedback was making your VGS to further reduce so that you could able to get a balanced value of what ID. Here it is not so.
Sir.
Here it is actually, that's why I didn't write it as RS. I wrote it as R signal, because R signal is the resistance that is there associated with the source, associated with
Yes,
your input source, not the source of your what MOSFET. Okay, that's fine. So let us move on to okay. Let us find what is the what in output impedance. So what will be the output impedance? Okay, you can just see over here. Now we are supposed to find what is now for finding output resistance. Let us consider R naught. Okay, lambda is non-zero. Lambda is non-zero. Can you see here? Since this Vin is having some RS as per the textbook, Can you see when you ground that V in, that R signal will going to come into picture?
Yes, sir.
Let me just draw the picture circuit over here. Now you can see. So I have this as my circuit. So what is the circuit now? This is my V in, and this is RD, and it is grounded, and sorry, uh, this is VB. Here you are applying V in. This is my R signal? This is my
Yes,
R
sir.
signal, and is this my what is that? VDD,
VD.
and here you apply VX.
VX.
Fine. So what we'll do is we'll just divide this into two different resistances. Here looking up is RD, correct?
Yes, sir.
Looking up from here, because this is what is the output resistance, which is nothing but this in parallel with this. Because you have some resistance looking down here, you have some resistance looking up here.
Yes, sir.
So let me just open circuit this and try to find out what is the resistance looking down here. So when I open circuit this, so I'll just write, this is my drain, this is Vx, this is Ix. I will make my Vn equal to 0. Why Vn should be 0? Because you are trying to find the output resistance, all input voltages should be grounded. Is this my R signal?
Sir. Yes, sir.
Correct. So, and since this lambda is non-zero for this, now I don't know whether you people still remember or not. Suppose if you have something over here, if it is AC grounded, if you look from the drain, what are the resistance? If lambda is non-zero,
1.
if lambda is non-zero, I ask you to remember someone.
Doctor.
What is the value now? This is
1
drain.
over.
Hey, doctor. You are remembering doctor, you are still writing 1 over, you are saying 1 over GM. What is doctor? Why do you remember doctor? Because doctor, you write it like this.
R naught.
Or not.
Yes, sir.
Doctor ಏನಕ್ಕೆ ಜ್ಞಾಪಿಸ್ಕೊಂತೀರಾ? Because there is a R
yes,
naught
sir.
in the doctor. Huh? Correct?
Yes, sir. Yes.
So now, suppose if you have this. Now you again see from here. What is the value now? What is the resistance looking down here? There is a R signal. Remember? Forgot. I said okay, these are all very important thing. It is R naught plus Rs into 1 plus Gm into R naught. This is, suppose if I write it as R out.
R out.
Don't remember?
Yes, sir.
Let me just show you that same thing. See here? This is what we did on that day. This is, you are looking from the drain, there is a Rs connected, the resistance looking down is R naught plus Rs into 1 plus Gm R naught. Correct? Hello, Shilpaji.
Hello.
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 Hello. Hello.
Hello.
Hello. Am I not audible?
Hello, sir.
Hello. Hello.
Hello.
Can somebody text, okay, am I audible or not? Am I audible? For Shilpa, I'm not.
Hello. Hello, am I audible, sir?
You are, but I'm not audible to you.
Hello.
Okay, can someone, Maulia D, can you just unmute? Maulia? Hello.
Hello, sir.
Okay, Maulia are there?
Yes, sir.
Okay. Now, we were trying to just find out what is the resistance that you see down towards the drain if an R signal is connected at the source? Is this the value? Okay, let me write it as R signal. Hello.
Yes, sir.
Is that fine?
Yes, sir.
Okay, now what is, suppose this is R out looking down here. This is R out. Looking up is how much? Looking up is how much? Hello. This is RD, no? Hello.
Yes, sir.
So,
Sir, your voice is lagging for me.
is it? What to do now?
Yes, sir.
The network problem. I don't know. Okay, what I'll do is, let me just, okay, stop, and then how about now? Now also lagging.
Yes,
Hello.
sir. Abhi.
Now also lagging.
Yes, sir.
Okay, I don't know when I lead. Okay, before I speak, something should come out. So that is called as leading. I think it will never happen. So only lagging will happen because of this network. So I think, is it fine now? I don't know. What can I do? Let me just stop sharing. This is camera. And then let me share this also. How about now?
Fine, sir.
Now it is fine. Okay, fine. Uh, now who is there with me? Now it is Molia.
Yes, sir.
Yeah, fine. So we were trying to find out what is the resistance looking from the drain towards, okay, from here towards drain point. Is it not, okay, R naught plus R signal into 1 plus Gm into R naught?
Yes, sir.
Again from the same point, you just look towards up, that is towards VDD. Is it not RD?
Yes, sir.
Now see here, it is something like this. You are standing here. If you look down here, it is, what is that? R naught plus RS into 1 plus Gm into R naught.
JM into R
If you
naught.
look up here, it is RD.
RD.
Correct? This is also AC
Yes, sir.
grounded. This is also AC grounded. If you look from here, are these two not coming in parallel?
Yes, sir.
So this is R out, which is looking down. This is RD. If you look from here, if I write it as R out dash, shall I write it as R out in parallel with RD?
Yes, sir.
So this is R out. This is R out dash. This is R out. This is RD.
Yes, sir.
So this is grounded. This is also grounded. Does these two grounds come together here? Does this RD and this R out comes parallel?
Yes, sir.
So R out dash is R out in parallel with RD. That's what
RD.
is there here in this. So here this is R out looking down, because there is no RD. RD they have taken out. RD they have taken out.
Yes.
If you consider RD also, then it will become what? This R out in parallel with RD.
Yes, sir.
Correct?
Yes, sir.
Okay. Just see this. Alap, just have a look at this. Don't worry too much. Now, this is also a CG amplifier. Can you see there is a M2 with drain connected to gate? Oliadi?
Yes, sir.
See, effectively, what will be the resistance offered by this M2? Is it not 1 over GM2 in pair with R02?
Yes, sir.
So, neglecting that, because R02 will be very high, so 1 over GM2 in pair with R02 will be close to 1
I'm
over
not.
GM2.
Yes, sir.
So, looking up here, is it the source terminal? Here M2.
Yes, sir.
So what is the
Yes,
resistance
sir.
looking up here? Is it again approximately equal to 1 over GM1?
1 over GM1.
So what is Vx in terms of V now? Is it now a potential divider where you have 1 over GM1 coming in
1
parallel
over
with 1
GM.
over GM2 and this is Rs?
Yes, sir.
Now can we write the expression for the voltage gain as, let me just show you in my, okay, what the circuit we have is, so I want all of you to write it. So I have a circuit which is something like this. This is Rs. I have this is M2. This is grounded. Sorry. I have this is M1. So there is a bias voltage. This is RD. Let me talk V0. This is M2. This is again VB. This is also VB, some voltage. This is RS. This is Vin. This is Vx. Am I correct?
Yes, sir.
So shall I write? Okay, our aim is to find what is AV.
AV.
When I say AV, it is output by input.
Output by input.
So shall
Yes,
I
sir.
write it as V0 by
Not
Vin?
by Vn.
Correct?
Yes, sir.
Shall I
Yes, sir.
multiply and divide by Vx?
Ex. Yes,
Vx is
sir.
this point. Because,
Yes, sir. Yes, sir.
so shall I write it as V0 by Vx into Vx by Vin?
In by Vn. Yes,
Correct?
sir.
V0 by Vx is
Yes,
what?
sir.
So this is V0 by Vx. So V0 by Vx I already know. I can write it as Jm into Rd. Because this is a CG amplifier with the input voltage as Vx, and if this is Rd, shall I write it as Jm into Rd?
Yes, sir.
So what I want to know is what is the ratio of Vx by Vin?
V.
Andre, what is the voltage at this point due to this?
Okay, sir.
So shall we write this circuit as, this is Vin, this is Rs. Looking up here, how much?
R.
Ili.
1 over
Source
G.
1 over GM1.
1
Looking
over
down here,
GM1.
looking down here,
1 over GM2.
GM2. Is this Vx?
Yes, sir.
Does these two come in parallel?
Yes, sir.
So shall I write Vx as equal to
V.
Vin into 1 over
1
GM1
over
parallel
GM1
with
in parallel
1
with
over
1 over
GM2
GM2.
divided by Rs or R signal everything. R signal plus 1 over GM1 parallel 1 over GM2. Very good.
Yes, sir.
So actually 1 over GM1 parallel with 1 over GM2 can be written as 1 over GM1 plus GM2. ಅದು ಯಾವಾಗ derivation ಮಾಡ್ಕೊಳ್ಳಿ ನೀವು. So whenever you are, because if you want to clarify, this is so and so. So what
Okay,
I'll
sir.
do, I will rewrite this as Vx is equal to Vin. Shall I write it as 1 over GM1 plus
Plus GM2.
GM2 divided by R signal
R signal.
plus 1 over GM1 plus GM2.
GM2.
I'll take the LCM. So will it now be V in into
V
1 plus
divided by
R signal
signal
GM1 plus GM2.
into GM1 plus GM2.
Because I know all of you are very good in mathematics. Is this fine?
Yes, sir.
Shall we now write Vx by Vin as 1 over 1 plus R signal into
Into
GM1
GM1
plus
plus
GM2.
GM2.
If R signal is 0, what is Vx and Vin? ಇಲ್ಲಿ ನೋಡಿ.
1.
Suppose if R signal is 0, whatever is the input voltage, that is Vx. That is true also
Yes.
here. Is it not? If R signal becomes 0,
Yes,
then
sir.
Vx is equal to Vin, which is true here.
Yes, sir.
So can we now substitute this here? So then what is V0 by Vin as? Is it not 1 over 1 plus
1
R
plus
signal GM1 plus GM2 into GMRD.
Yes, sir.
So this is what is V0 by Vx.
V0 Vx.
Am I correct?
Yes, sir.
This is V0 by Vx, whereas this is Vx by Vin.
Vx by Vin.
So the product is V0 by Vin, which is nothing but A. Correct?
Yes, sir.
That's what is there here also. Can you see here? You have only one step. Suppose if
Yes.
you read only the textbook, you'll go mad. V0 by V0 by Vn is GM1 into RD by, of course, I have not written GM1.
1
Let
plus
me write it GM1. Okay, here in my notebook also it is GM1 into RD by 1 plus R signal GM1 plus GM2. That's what is there here. Instead of R signal, they have written it as RS. Correct?
Yes, sir.
What is R out? That is interesting. Looking up here, can you see what is R out 1?
Around 1.
See, how do you find R out 1 is? Can you see, will you be grounding this Vin?
Yes, sir.
So when you ground it, will it be only RS?
Yes, sir.
What is looking down here? Is it not 1 over GM2 in parallel with
1 or
R02?
GM2 in parallel with R02.
Correct?
Yes, sir.
And does these two come in parallel? See here,
Yes,
this is
sir.
ground, this is ground. So
Yes,
looking
sir.
out this, looking towards this side, is it not R01 plus of 1 plus GM1 into R01 multiplied by this quantity? So what I'll do is, okay, let me just rewrite this. This is M2, this is VB, this is VDD, this is RD, this is V0. Okay, this is R signal, this is M2, this is M1. Am I correct? Okay, let me just show you that. Am I correct? This is again VB.
Yes, sir.
This is Vin. So what is the intention? Your intention is to find what is
Fine.
overall output
Overall
resistance.
output
Output resistance. Let me write it as R out or R out dash or whatever. So does this resistance, shall I write it as this in parallel with this? Let me write R out up and R out down. So what is actually R out now? R out, shall I write it as
R
R out
out in parallel
up
with R
in
out
parallel
down.
with R out down, so that you can understand.
Yes, sir.
What is R out up looking up? Is it not RD?
RD.
Shall I write looking down as R out dash?
Yes,
Let
sir.
me name this as R out dash. So shall I now
Yes, sir.
write R out dash as equal to, sorry, this is not VB. I think it is something like this. Am I correct?
Yes, sir.
Let me just have a look at it. Okay, it is gate and drain are shorted. Correct.
Yes, sir.
So is this now R01 plus 1 plus GM1 R01?
R0
What is this? Is it now RS in parallel with, what is the
R
resistance that you are
signal
looking down here? Is it 1 over GM2 in parallel with R02?
in parallel with R02.
Correct?
Yes, sir.
So this is what you are seeing here. ಇಷ್ಟು ದೊಡ್ಡ expression ಇದೆಯಲ್ಲ. So don't go mad here. It is as simple as that. See now, it is R01, correct?
R0. Yes, sir.
So that's what I have in my, can you see this R01?
Yes, sir.
And multiplied by 1 plus GM1 into R01. which is 1 plus GM1 into R01.
R01.
This is what gain of this amplifier, intrinsic gain of that amplifier, correct?
Yes, sir.
Which is multiplied by the resistance of this network. The resistance of this network. What is the resistance of this network now? It is RS in parallel with this. That's what it is. RS in parallel with 1 over GM2 in parallel with R1.
1 hour gym.
Correct?
Yes,
That's
sir.
what is this. Correct?
Yes, sir.
See now, they are writing approximately, they are taking out this 1. And they are taking out this highest value of these 3 is R0. Hello?
Yes, sir.
When you have something in parallel, it is better to neglect the highest of all the 3, all of them. The highest of 1 over GM, R02 and RS is R02. That's why
Yes.
you are neglecting that R02. So that's why you're writing 1 over GM2 in parallel with RS.
Yes, sir.
Because there's a doubt comes, okay, why did they neglect R02? Why they didn't neglect RS? Because RS will not be so high when compared to R02.
Not 2.
And why they are neglecting 1 here is because GM into R0 is very high. Plus 1 will not make much
1.
difference. So if I just come back to my notes, so shall I now write R0 dash as equal to R01 plus
R01 plus
GM1 into
GM1
R01
to R01
RS parallel with
plus
1 over
1 over
GM2.
GM2.
This is approximately. So what is overall R out now? RD, which is looking
RD
up
in parallel.
parallel with R01 plus
R01 plus
GM1 R01.
GM1 R01 into RS in parallel with 1 over GM2.
This is your R. Fine. This is what is there.
Yes, sir.
As simple as this. Now getting some confidence.
Yes, sir.
Yeah, this all. Now, if don't panic when you look at such a complicated circuit. So it just boils down to a very small resistance of very small equivalent circuit, and it just this becomes very clumsy or very difficult, but it is not difficult. It is as easy as we just solved it out here. See this now. This is the actual circuit how it looks.
Yes.
Because usually you're going to have a coupling capacitor to ensure blockage of DC, correct?
Yes, sir.
And you will have a resistor R3 so that some voltage, because if you don't see here, whenever I put a capacitor here, so if there is a drain current, if there is a DC current flowing here, if there is a capacitor here, then DC current is not at all allowed to flow if there is no R3. Hello?
Yes, sir.
Assume here, let me just go down to this. What is usually, how does your CG amplifier look like? This is how your, this is V in, this is VDD, this is RD, this is V0, this is fine, this is V in. But typically you'll not have a input source which is connected to the gate. So what I'll do, I will just take out this source and I will put V in here, because this is having some effective resistance RS.
Resistance.
This may have some DC voltage that may affect my VB. So what I'll do, I will put a capacitor. When I
Okay, sir.
put a capacitor, now how does the circuit will look like? The circuit will look like this. This is how your circuit is looking.
Yes, sir.
Because why you put this CC? Why you put this CC? So that you couple only the AC
Sir.
signal.
AC signal.
Correct? So in
Yes, sir.
such case, can you expect to ID to flow here?
ID.
ID will it
Yes,
flow
sir.
from VD to ground? Will it flow? Capital ID. it won't flow because this is a capacitor which blocks the DC.
Capacitor block. Yes, sir.
So you are supposed to use a coupling capacitor to not to disturb the DC voltage, but you should
Yes.
allow this DC current to flow also. You put a resistor R3 now. The
Okay, sir.
purpose of putting this R3 is to make ID to flow through this. If there is no R3, the ID would have not flown at all.
ID on.
So then if there is no ID, there is no GM. If there is no GM, there is no gain.
Okay, sir.
So can you now tell me what is Vx? Shall I now
Yes.
write Vx as equal to what is looking up here? Source.
So yes, sir.
Resistance ಎಷ್ಟಿರುತ್ತೆ?
1 over.
1 over GM.
Yes, sir.
Does that 1 over GM come in parallel with R3?
Yes, sir.
Shall I write it as V in into 1 over GM1
GM
parallel with R3
parallel with
divided
R3.
by R signal plus
Signal
1 over GM1
1 over
parallel
GM1
with
in
R3.
parallel with R3.
This is Vx. That's what you have here. See here? First it is again Vx by Vn. Can you see here R3 in parallel with 1 over Gm
1 over
divided by
GM1.
R3 plus 1 over Gm plus R signal
R
multiplied by
signal.
Gm into Rd. What is this Gm
Yes,
into
sir.
Rd?
V in.
No, Gm into Rd. This is the gain of your CG amplifier.
Yes, sir.
See, ultimately as we did in the earlier case also, you are supposed to find V naught by Vn. Correct? Huh?
Yes, sir.
Shall I write V naught by Vx and Vx by Vn? What is
Yes,
this?
sir. GM into RD.
What is this? It is this.
Yes, sir. 1 over GM1 in parallel with R3 divided by.
Suppose if you keep telling, of course, the people who are not seeing this, they may go mad. Okay, what is this student or what is this sir is telling about? Suppose if you look at this, it is so easy. Is this is AV now?
Yes, sir.
For this practical circuit,
Yes, sir.
okay, that's it. So, can somebody say what is R out of this? Overall R out looking parallel. Is it not RD in parallel with R naught 1 plus 1 plus GM1 R naught 1 into what? What do you have? Is it not R3 in parallel with R signal? Because when you ground this, what will come in parallel? These will come in parallel.
R3.
R
Yes, sir.
signal and R3 will come in parallel. That will be seen as a heavy resistance by 1 plus GM into R naught times
1 plus
plus
GM.
R naught in parallel with R. This is R up, correct? This is R down.
Yes, sir.
R down is R naught plus this resistance coming in parallel multiplied by intrinsic gain. How many of you gone mad? Maulia, have you gone mad? Okay, is it fine?
No, sir.
Okay,
Fine,
fine,
sir.
fine. Okay, let me just know from the class. Okay, how is this? Can you able to appreciate how do you find R out? This is R out. Of course, sometimes I may say this is R out, that is R out dash, but R out is now I'm just looking from here, which is nothing but this in parallel with this. So just put in the chat box. Okay, could you able to find out what is how to find the gain of an amplifier and R out of the amplifier? Quickly say yes, no. If you have any doubt, let me just know. AMCD is only this much. If you can catch hold of this, then you can rule AMCD. This is exactly there in your textbook. You can see this is what you have, and of course we have some problems also. You can just work on that. Of course we'll just work on that. Then maybe in the afternoon class we'll just see a few more problems on CG amplifier and then move on to CD amplifier. Okay, if it is fine, if everything is fine, then we'll close today's class. Thank you so much.